What's up guys, this is Massey. Welcome to another video. In this video I want to talk about reaction mechanism. Most chemical reactions occur by a series of steps called a reaction mechanism. For example, consider this reaction: NO2 plus CO gives NO plus CO2. The rate law is rate equals to K, which is the rate constant, times NO2 to the power of 2. It means that the concentration of NO2 to the power of 2. If you compare these two, it looks like the rate law is complicated. Why? Because the balanced equation, as you see here, for a reaction tells us about the reactants, tells us about the products and the stoichiometry, but gives no direct information about the reaction mechanism. So as you see here, when you consider this balanced reaction, you know the reactants, you know the products, and you know the coefficient of each of the reactants and products. But it doesn't give us any information about the rate law or reaction mechanism. For the reaction between nitrogen dioxide and carbon monoxide, as you see here, the mechanism is thought to involve the following two steps. So here we are dealing with an overall reaction. However, we have two elementary steps involved. The first elementary step is NO2 plus NO2 gives NO3 plus NO, and on the second elementary step we have NO3 plus CO gives NO2 plus CO2. So we are dealing with two elementary steps, and K1 and K2 are rate constants for these two elementary steps. Now, as you see here, we have NO3 in these two elementary reactions. As you see here, on the first one, NO3 is formed, and on the second elementary step, NO3 is consumed. So NO3 is the product of the first elementary step and is the reactant in the second elementary step. However, you don't see it in the overall reaction. So NO3 is called intermediate, and intermediates are those species that is neither a reactant nor a product, but that is formed and consumed during their reaction sequence. So each of these two reactions is called an elementary step. The reaction whose rate law can be written from its molecularity. What is molecularity? Molecularity is defined as the number of species that must collide to produce the reaction indicated by that step. What does that mean? To write a rate law based on its molecularity, it means that if you are dealing with an elementary step, for example, for the first one, the rate is going to be equal to K1 times concentration of NO2 times concentration of NO2, or rate of the first one equals to K1 times concentration of NO2 to the power of 2. And the rate for the second elementary step is going to be equal to K2 times concentration of NO3 times concentration of CO. However, if you are dealing with an overall reaction, we cannot say such a thing. As you see here, you can find out the difference. So you cannot directly write the rate from an overall reaction. Only we can do it for elementary steps or elementary reactions, because we write the rate law based on the molecularity. A reaction involves one molecule is called unimolecular step. Reactions involving the collision of two or three species are termed bimolecular and termolecular respectively. So if you have two species, it's going to be bimolecular. If you have three of them, it's going to be termolecular. Termolecular steps are quite rare because the probability of three molecules colliding simultaneously is very, very small. So let's see some examples of elementary steps. Elementary step, if we are dealing with unimolecular, it means that we have only one species. A gives products. We can write the rate law as K times A. If we have bimolecular, for example, A plus A or 2A gives product, it's going to be rate is going to be K times A squared. A plus B gives products, bimolecular, so it's going to be rate equals to K times A times B. 2A plus B gives product is going to be termolecular because we have 3 of them. So rate is going to be K times A squared times B. And finally, when we have A, B, C, 3 different reactants, again termolecular, rate is going to be K times concentration of A, concentration of B, times concentration of C. As you saw, the last 2 is rare. So it is a series of elementary steps that must satisfy two requirements. So we are dealing with reaction mechanism. So we need to have these 2 requirements. The sum of the elementary steps must give the overall balance equation for the reaction. So it means that these 2 elementary steps must result in the overall balanced reaction. Second one, the reaction mechanism must agree with the experimentally determined rate law. I will explain it later on, because you need to know the concept of rate determining reaction. So now when we have the elementary steps, we have NO2 plus NO2 gives NO3 plus NO. And the second elementary step is NO3 plus CO gives NO2 plus CO. When you add these 2, it's going to be NO2 plus NO2 plus NO3 plus CO gives NO3 plus NO plus NO2 plus CO. Now, what you can do, you can cancel NO3, and you can also cancel one of the NO2 from both sides. So the overall reaction is going to be NO2 plus CO plus gives us NO plus CO2, as you saw it originally in the overall reaction. Now there is a concept called rate determining step. Rate determining step. It means that when we have reaction mechanism and we list the elementary steps, one of them is gonna be the slowest in terms of rate. That slowest elementary step is gonna be rate determining step that determines the overall rate of reaction. So when we are dealing with multiple reactions, often have one step that is much slower than all others. The overall reaction can be no faster than the slowest or rate determining step in the sequence. So rate determining step, which is the slowest one, is gonna determine the rate of overall reaction. For instance, in these 2 elementary steps, the first one is the rate determining step because the slowest one. So that's why the rate of formation of NO3 is going to be K1 times NO2 to the power of 2. And since the overall reaction rate can no faster than the slowest step, the overall rate is going to be exactly the same as the slowest one. Let's see some example. The balanced equation for the reaction of the gases nitrogen dioxide and fluorine is 2NO2 plus F2 gives us 2NO2F in gaseous phase. The experimentally determined rate law is rate equals to K times NO2 plus F2. A suggested mechanism for this reaction is NO2 plus F2. K1 gives NO2F plus F, and on the second one, F plus NO2 gives us NO2F. The first one is slow, the second one is fast. Is this an acceptable mechanism? So first of all, we need to add these 2 elementary reactions to see if we get the overall one or not. That's going to be NO2 plus F2 plus F plus NO2. Give me NO2F plus F plus NO2F. So one F and F cancels out. We have 2NO2 plus F2 gives us 2NO2F. Now if you compare it with the overall reaction, that matches 100%. Now let's take a look to the mechanism. the slow one, the rate determining step is NO2 and F2. And the rate law for the overall reaction is K times NO2 times F2, which makes sense due to the molecularity of the slowest step. So that mechanism is acceptable. Let's see another example. A proposed mechanism for the reaction is these three. Write the rate law expected for this mechanism. What is the overall balanced equation for this reaction, and what are the intermediates in the proposed mechanism? So let's start with the first one. It says write the rate law expected for this mechanism. So we need to find out which one is the rate determining step. As we saw, the slowest one is going to be rate determining. So R, or rate, equals to K times C4H9Br. So that's going to be the rate law. What is the overall balanced equation for this reaction? We need to add them all. So it's going to be C4H9Br plus C4H9 plus H2O plus C4H9OH2 plus H2O gives C4H9 plus Br minus plus C4H9OH2 plus C4H9OH plus CaH3O plus. So now we can cancel them. We have C4H9 plus this side and this side, they cancel out. We have C4H9OH2 plus, cancel, and cancel here. What else do we have? It looks like we have no more. So that's gonna be C4H9Br plus 2 water molecule gives us Br minus plus C4H9OH plus H3O plus. That's gonna be the overall reaction, overall balanced equation for this reaction. Now, on the third part, it says what are the intermediates in the proposed mechanism. So we saw intermediates are those compounds that they are formed and destroyed or consumed during the reaction. So in this 3 elementary steps, this one is formed and consumed, this one is formed and consumed. So it's going to be C4H9 plus and C4H9OH2 plus. So these are the intermediates of this reaction. Let's see another example. The mechanism for the gas phase reaction of nitrogen dioxide with carbon monoxide to form nitric oxide and carbon dioxide is thought to be this and this. Write the rate law expected for this mechanism and what is the overall balanced equation for this reaction. We saw this example before, so it's going to be rate equals to K times NO2 times NO2, which is going to be to the power of 2. Why this is going to be the overall rate? Because we write it based on the slowest step in this mechanism. And write the overall balanced equation, we need to add them. It's going to be NO2 plus NO2 plus NO3 plus CO gives us NO3 plus NO plus NO2 plus NO2. That's actually CO2. So what we can do, NO3 and NO3 cancels out. One of the NO2 and NO2 cancels out, so it's going to be NO2 plus CO gives us NO plus CO2. That's going to be the overall reaction. Let's do the last example. It says write the rate laws for the following elementary reactions. So since there are elementary reactions, we can write down the mechanism based on the molecularity. So A is going to be, let's call it K1, K2, K3, K4. So rate R let's say Ra equals to K1 times, we have only one molecule, unimolecular, and C. Rb is going to be K2, that's bimolecule, ozone times NO, because we have two reactants. C is going to be Rc equals to K3 times O3, that's unimolecular again because we have only one reactant, and D is going to be Rd equals to K4 times O3 times O. That's going to be bimolecular. So that's what I had for reaction mechanism. I hope you enjoyed this video. Please leave me a comment if you have any question. Please don't forget to subscribe this channel if you like this video. You can have access to many other videos regarding chemistry, physics, and math. Thank you for watching and have a great day.